Have you ever wondered how a simple flip of a switch can light up an entire room? It's a common scene in our daily lives, but the magic behind it is often overlooked. So, what's the secret? It's electricity, an invisible form of energy that's always around us, even though we can't see it. Imagine a world of invisible, charged particles buzzing around us, carrying energy from one place to another. That's essentially what electricity is. It's the movement of these particles, called electrons, that generates the energy we use to power our lives. From the light bulb in your bedside lamp to the smartphone in your pocket, electricity is the driving force behind them all. But what makes these charged particles move? Well, it's a little like a game of tag. Electrons are always trying to get away from each other, but at the same time, they're attracted to protons, their positive counterparts. This push and pull, or attraction and repulsion, is what drives the flow of electricity, or current as we often call it. Every day we harness this invisible power to light up our homes, to keep our food fresh in the fridge, to heat our water and to charge our devices. We use it to communicate, to entertain, to learn, and to work. It's hard to imagine a world without electricity, isn't it? But even though electricity is such a fundamental part of our lives, many of us don't fully understand it. We take it for granted, flipping switches and plugging in cords without a second thought. But understanding this invisible power can help us use it more efficiently, more safely, and more consciously. So next time you flip a switch or charge your phone, remember the world of invisible charged particles that's working tirelessly behind the scenes. Remember the game of tag that's driving the flow of current. And remember the importance of this invisible power in our lives, because electricity is more than just the flick of a switch, it's the invisible power that lights up our world. But what exactly is electricity? This question seems simple, but the answer is surprisingly complex. At its core, electricity is the flow of electrical power, or charge. It's a form of energy that comes about through the movement of charged particles, typically electrons. In fact, the word electricity comes from the Greek word electron, which means amber. This is a nod to the ancient Greeks who discovered that rubbing amber produced an attractive force, what we now know as static electricity. Now let's delve a bit deeper. You might think of electricity as a primary source of energy, but it's actually a secondary source. This means we get electricity from the conversion of other sources of energy. These primary sources of energy can be either renewable or non-renewable. Non-renewable sources include fossil fuels like coal, natural gas, and oil. These are burned to create heat, which is then used to generate electricity. On the other hand, renewable sources of energy like solar power, wind energy, and hydroelectric power are naturally replenishing. For instance, solar panels convert sunlight directly into electricity, while wind turbines and hydroelectric dams generate power by harnessing the kinetic energy of wind and water. Nuclear power is another significant source of electricity. Nuclear energy comes from splitting atoms in a reactor to heat water into steam, turn a turbine, and then generate electricity. While nuclear power does produce a significant amount of electricity, it's not without its controversies, mainly due to the long-lived radioactive waste it produces. So, as you can see, electricity is a versatile and vital form of energy that we derive from various sources. It's a secondary energy source that we've harnessed to power our lives, from the smallest smartphone to the largest city. Without it, our modern world would look very different indeed. In essence, electricity is the lifeblood of our modern world, powering everything we use and do. Did you know there are two types of electricity? That's right, our world is powered by not just one, but two types of this incredible force. We've got static electricity on one hand, and current electricity on the other. Let's start with static electricity. You've probably experienced this phenomenon without even realizing it. Ever rubbed a balloon on your hair and noticed how it magically sticks? Or perhaps you felt a tiny zap when touching a metal doorknob. That's static electricity in action. It's electricity that is stationary or collects on the surface of an object. This happens when there's an imbalance of negatively charged electrons and positively charged protons. When these charges build up and can't find a quick route to escape, you get static electricity. Now let's move on to current electricity. This is the type of electricity that powers your life, from the device you're using to watch this video, to the light bulbs illuminating your room. Current electricity is a steady flow of electrons, moving very rapidly through a conductor. Unlike static electricity, these electrons have a clear path to follow, usually in the form of a wire, allowing the electricity to power various devices and appliances. To put it simply, static electricity is like a traffic jam. The electrons are all stuck with nowhere to go, causing a buildup of energy. Current electricity, on the other hand, is like a superhighway, with electrons zipping along at incredible speeds, delivering energy to wherever it's needed. So whether you're experiencing the hair-raising effects of static electricity or enjoying the benefits of current electricity powering your favorite gadget, it's clear that electricity, in all its forms, is an essential part of our daily lives. It's a fascinating and powerful force, one that scientists are still studying to fully understand and harness. Whether static or current, electricity remains a fascinating and powerful force. So, how does this electricity power our world, you may ask? Well, it's a fascinating process, and it all begins at power plants. These power plants, which can be fueled by coal, natural gas, nuclear energy, or renewable sources like wind and solar power, generate electricity. This electricity is then transformed into a high voltage by transformers, making it ready for its journey. Imagine the electricity as a marathon runner, and the power plant as the starting line. The runner, all charged up, embarks on a long-distance race, traveling through a complex network of power lines. These power lines are like the race route, guiding our runner to the finish line, our homes. But the race doesn't end there. Upon reaching our homes, the electricity has to go through another transformation. The high-voltage electricity is stepped down by smaller transformers, making it safe for use in our homes. Now, our runner is ready to power our devices, appliances, and lights. Think about it. The light that allows you to read your favorite book at night, the refrigerator that keeps your food fresh, the computer that connects you to the world. They're all powered by this incredible journey of electricity. It's a journey that takes place in the blink of an eye, yet it's one that powers our everyday lives. And it's not just our homes. Electricity powers our schools, hospitals, factories, and offices. It powers our cities, making them vibrant hubs of activity even after the sun sets. It powers our transportation systems, allowing us to travel great distances in a short amount of time. It's hard to imagine a world without electricity. So, the next time you flip a switch or charge your phone, think about the journey that electricity has taken to reach you. Think about the power plants, the transformers, and the miles of power lines. And most importantly, think about the power of electricity. It's truly amazing how this invisible force can do so much. What does the future hold for electricity? This is a question that has been bouncing around in the minds of scientists, innovators, and thinkers across the globe. And the answer? Well, it's as electrifying as the subject itself. As we move towards a more sustainable future, the focus is shifting towards renewable energy sources. Solar power, wind energy, hydropower, and other forms of renewable energy are becoming increasingly popular. The sun, the wind, and the water around us are not just elements of nature anymore. They are potential powerhouses, capable of providing us with the electricity we need. And it's not just about generating electricity, it's also about how we use it. That's where smart grids come into play. These are electricity networks that use digital technology to monitor and manage the production and consumption of electricity. They optimize the way we use electricity, reducing wastage and making energy use more efficient. Then there's the electrifying revolution in the world of transport. Electric vehicles. Cars and bikes that run on electricity instead of fossil fuels are no longer a thing of the future. They are here, and they are changing the way we travel. Electric vehicles are not just cleaner and more efficient, but they also hold the promise of a future where our travel doesn't harm the planet. But the future of electricity isn't just about technology. It's about a shift in mindset. It's about understanding that our planet's resources are finite, and that we need to use them responsibly. It's about realizing that every bit of electricity we use comes at a cost, not just in monetary terms, but also in terms of the impact on our planet. The future of electricity is bright, and it's clean. It's about harnessing the power of nature, using technology to optimize its use, and shifting towards a more sustainable lifestyle. As we move forward, the role of electricity in our lives will only continue to grow, lighting our path into the future.